Alright, so Algebra 2 Trick Honor students. So this one is the last part of Chapter 8, so Part 4. So finding the sum for the infinite geometric series. So let's talk about the infinite geometric series versus the regular geometric series. Okay, so let's go to this one. So the way to find out the sums of any regular geometric series, then that would be considered this formula right here. So a sub 1 times 1 minus r to the power of n over 1 minus r. If that's infinite geometric, so that means you started with 1, and then the next number is 1 half, and then 1 4, 1 8, 1 over 16. And as you can see that this number is getting smaller and smaller, and eventually, guess what? It's getting close to 0. So if you see the common ratio, it's, well, absolute value of the common ratio, it's less than 1. So that means it's considered an infinite geometric series. So if that's a regular geometric, it's like 1 times 2 times 4 times 8 times, well, 1, 2, 4, 8, and then 16, so on and so forth. The number is getting bigger and bigger, so eventually it's getting close to infinity. But for the infinite geometric, the number is actually getting smaller and smaller and smaller, so eventually it's getting close to 0. So now we'll take a look at the example here. So the way to find out the sum of the geometric series, so we're going to use this formula. So instead of using that, the summation, so this one will be written as a sub 1 divided by 1 minus r. Well, because that, you try to combine all this together. Well, the first number, you don't change that. But for the rest of this, it looks like the other one, they're getting closer and closer to what? 2. So once you combine them all together. So it's going to be another 1 again. So 1 plus 1, then that'll be 2. So that's why we're using the shortcut formula for the infinite geometric series. Okay, so now let's find out. So we do have a sub 1, so that's negative 972. Common ratio is 1/3. So using that formula, so we do have a sub 1 divided by 1 minus r. So negative 972 divided by 1 minus 1/3. So negative 972 divided by 2/3. So in other words, that means you multiply by the reciprocal. So multiply by 3/2. So once you cross cancel, so 2 goes into negative 972 how many times? So 972 divided by 2. Okay, let's see. So negative 486 times 3. 6 times 3 is 18. 8 times 3, 24, plus 1, 25. 4 times 3, 12, plus 2. So negative 1,458. And then that'll be the sum of this infinite geometric series. So check it out, 52. So negative 1,458. And then the other one, so basically using that the same formula, plugging that to the equation. And now what about if the sequence pattern is given here? So a sub 1, it's given, it's 1. In order to go from one term to the next term, so this one you multiply by what? Negative 1/5. Because positive to negative, negative to positive. So the sign, it just alternate. So using that, the summation formula for the infinite geometric series. So a sub 1, it's 1, divided by 1 minus negative 1/5. So it's just 1 divided by, well, negative, negative, positive. So 1 plus 1/5, which is what? 6 over 5, divided by 6 over 5. So in other words, it's what? 5 over 6. So that's the sum of this infinite geometric series for 56. Check that. Yeah, 5 over 6. Okay, so now let's see what else. And what about for this one? So it's all decimals. So again, so A1, it's given, negative 7.8. And then just find a common ratio. So the way to do it, so simply multiply this one by 2. Yeah, simply multiply by 2. So common ratio is 2. So using that, the summation formula, so a sub 1 over 1 minus r. And the reason why that I do know this one is geometric, well, let's see, got to be careful. So if the common ratio, it's less than 1, absolute value of the common ratio, like the previous one, it's less than 1, so we can use that a sub 1 over 1 minus r. But it looks like the common ratio here, it's actually greater than, okay, let's see. Oh, you know what? It's not 2, it's 0.2. Because that's 1 decimal place to 2 decimal places. So this one got to be careful. So this one is 0.2. So the easy way to find out the common ratio is just simply divide it. Or simply, just divide it. So it's what? Negative 7.8 over negative 1.56. So it just convert it. Then that would be 78 over 156. And reduce it, so it's 1 over 2, which is what, 0.5. So multiply by 0.5 or divided by, no, multiply by 2. Multiply by 0.2. Yeah, so just multiply by 0.2. So instead of dividing it, so this one basically just multiply by 0.2. So check that, you'll get to the next number. So 7.8 times 0.2. So 8 times 2, which is what, 16? 7 times 2, 14, plus 1, 15. So 2 decimal places, 1.56. So negative, negative, so there's no need to change the sign, so multiply by 0.2. So using that common ratio, A1, so negative 7.8. divided by 1 minus 0.2. So negative 7.8 divided by 0.8. So this one, we write it as negative 78 over 8. Reduce it. So then that would be considered, well, is that divisible by 4? No, it's divisible by 2. So divided by 2, 4, divided by 2 here, negative 39. Negative 39 over 4. So 58, check it out. So negative 9.75. It is, right? Let's divide it. 9 times 4, 36. 3, bring down to 0. 7, 28, 2. So negative 9.75. That's right. And now what about for number 60 and number 62? So again, this one, it shows that the common ratio is what, 1/2. Again, the structure for the arithmetic, for the geometric series, it's A1 times common ratio r to the power of n minus 1. So the common ratio is 1/2. So A1, which is what, 5. Again, using that formula. So A1, 5 over 1 minus 1/2. So we do have 5 divided by 1/2. So 5 times 2, which is what, 10. And this one also, A sub 1 is 4. Common ratio is 1/2. So 4 over 1 minus 1/2. So 4 divided by 1/2, which is what, 8. So for 60 and 62, so 10 and 8. Yep. Okay, so now this time we need to find out the value of n. Okay, so the sum is given already. And we do know that this one is under the structure of the geometric sequence formula. A sub 1 times common ratio r to the power of n minus 1. So A sub 1, this one is considered 1. But the common ratio here, it's 5. So instead of using that, the A sub 1 over 1 minus r formula, so we're using that, the regular geometric sum formula. So S sub n equals a sub 1 times 1 minus r to the power of n over 1 minus r. So 156, so that's S sub n, and then a sub 1, and we do know that it's 1 because that's just the leading coefficient. And then 1 minus the common ratios, 5 to the power of n over 1 minus r, so 1 minus 5. So 1 minus 5, that's negative 4. So 156 equals negative 1/4. So that equals 1 minus 5 to the power of n. Multiply by negative 4 both sides. So we do have 6 times 4, 24. 5 times 4, 20. 22. 1 times 4 plus 2. So negative 624. And then subtract 1 on both sides. So negative 625. Negative, negative, positive. So 625 equals 5 to the power of n. And n, we just consider, what is it? To the 4th power. So 5 squared, then that's 25. Yeah, 5 to the 4th power. So 5 times 5 times 5 times 5, 625. And then here's another one. So a sub 1 this time, it's what? Negative 2. And then common ratio is 3. The sum is negative 26. So that equals negative 2 times 1 minus r to the power of n. So 1 minus 3 to the power of n. All over 1 minus 3. So 1 minus 3, negative 2. So negative 2 got canceled. So negative 26 equals 1 minus 3 to the power of n. So subtract 1 both sides. So let's see right here. Anything went wrong here is 3 to the power of n. Okay, a sub 1 is negative 2, so 1 minus 3 to the power of n. So once you subtract 1, then that'll be negative 27, that's right. Equals negative 3 to the power of n. Negative, negative got canceled, so 27 equals 3 to the power of n. And then n equals what? 3. So determine the common ratios of the infinite geometric series. Well, this one is pretty straightforward. So the sum is given already, negative 4/3. So we're using that a sub 1 over 1 minus r. So negative 4/3. So that equals a sub 1, negative 1. Divided by 1 minus the common ratio. Okay, so that's what we need to find out, common ratio. So this one cross multiply. Or negative, negative got canceled out, so it turns out to be what? Positive. So 4 times the quantity of 1 minus r equals 3. So 4 minus, another way you can do it besides distributing that 4 here. Oh jeez, this one is not erasable. Here we go. So divided by 3 first, so 1 minus r equals 3/4. So that means r equals what? 1/4. And then the other one here, the sum is given 5. So a sub 1/4 over 1 minus r. Cross multiply, so we do have 5 times 1 minus r equals 4. So in other words, 1 minus r equals 4/5. So r equals what? 1/5. So 68, 70, one is 1/4, the other one is 1/5. Check the common ratios, 68 and number 70. Yep, it is. So basically, once you know the formulas, it's all about putting the number and then find out the unknown. It's all algebraic work. Okay, so that's it. Thank you for watching the video today. See you next time.